how do we teach ontology and epistemology to? Can machines ever be ontologically and epistemologically aligned to us? I'm sorry, it's a long question. And if that is the case, then if we don't have foolproof evidence of how intelligent life started on our planet, then does it mean someone from other part of the universe had actually given us this intelligence like we are slowly and steadily giving it to machines? So what do you think?
Yes, from my perspective, I don't think there's really any strong evidence that intelligence came, anywhere other than through evolution. That basically,
Right.
we can follow the progress of intelligence as animals evolved. So I think it's pretty clear that, initially there was very simple stimulus response mechanisms that evolution, created. And those became ever more sophisticated. And the big leap between the higher animals and humans, and what makes human intelligence so uniquely powerful, is that we are able to form abstract concepts. Whereas, roughly speaking, and it's not a totally binary thing, but roughly speaking, animals can only form concepts that are directly linked to perception. So what they perceive, if they perceive different objects, a food bowl or a tree or an elephant or whatever it might be, if they see them or have other sensation, whether it's smell or sound or whatever it might be, they can basically form those concepts and say, well, this is something that's good for me, or that's something I can eat, or something that might eat me, and basically categorize different things like that. And with humans, we are able to form concepts of concept, really in an unlimited way. And, that's what abstract concepts are. And we can end up with extremely abstract things like government or marriage or honesty or, things like that, which are several levels high. So I don't think there's any evidence that, all the evidence points at that, evolution created the intelligence that we have. Now, as far as computers being able to acquire the ontology, as you said, or epistemology, the ability to learn, like humans, I think they need to be seeded with certain learning mechanisms. I mean, we are born with certain feature extraction, with certain ability to learn fundamentally. That's in our DNA. And then interacting with the environment, and this is where nurture comes in, basically, we develop this intelligence fully, as we interact with the world, and, for humans, having teachers, being able to read books and so on. So similarly, computers will need to have the innate ability to learn at a certain level. But that can be kind of a bootstrapping device, that innate ability that we need to build into the AIs can then lead the system to, learn and form these abstract concepts and learn similar to the way humans do. Now, we can vastly accelerate that learning process, of course, by immersing them in virtual worlds that are sped up, or even force feedings, frameworks, they can read Wikipedia and so on. So the learning process can happen much quicker, but ultimately they need to have those same advanced abstract concepts in their mind, in their architecture, in their mind, to be able to reason abstractly. And, at that point, basically, they will have the same ability to learn and reason, and basically the epistemology that you're talking about, and to build an ontology, to refine the ontology as they interact with the world.
That's fantastic. But then does it mean that it would take a long time to sort of do that for machines? Or do you think it's a step-by-step process? And is there enough research going on today in this regard?
Yeah. So, no, there's not enough research going on. Almost all of the research that's being done in AI is deep learning, machine learning, which is basically building statistical models, which are completely different. It's really the opposite of what you want. You want systems that can learn interactively and refine their models as they learn interactively. Even reinforcement learning, which sort of comes somewhat close to that, isn't really the right thing. I mean, it's a very small part of where we use reinforcement learning, in the kind of high level intelligence that we're interested in. Now, how long it should take, it's really depending on how good your kernel, the core mechanism is. And there's a lot of attempts and iterations one has to go through to build the machine that has the capacity to learn, by hitting the books, by, reading things, by talking to people, by potentially having sensors, being able to see the world, maybe being embodied in a robot or in a virtual robot. So it depends on how powerful the core machinery is. But apart from that, the acquiring knowledge really can happen very, very quick. I just went to this year's AGI conference a few weeks back, and, one of the speakers made the case and was totally convinced that the only way to build AGI is that it needs to be raised like an infant, like a child,
like a baby,
and like a baby, and there's no shortcut that, it's going to take you 18 years. Now, to me, that seems completely implausible. That thing. First of all, how do you debug it? How do you get you're going to have many attempts. There are a million ways of getting it wrong for every one way of getting it right. So you're going to have to run a lot of experiments and, to get those learning mechanisms to be correct, to get the curriculum to be effective, to have the scaling working, whatever hardware issues you may have and so on. So, and I see absolutely no reason why the learning process itself can't be sped up, thousands of times from human learning.
But how can that be sped up? Like you said, 1,000 times. How is it?
First of all, by reading. I mean, obviously, a computer could ingest Wikipedia, at 1,000 times or 1,000,000 times the speed that we could. I mean, in fact, we couldn't. We couldn't read it. But even to I mean, that's pretty clear. Once you have the mechanism for reading and comprehending there's no particular reason to think why you couldn't speed that up. I mean, in fact, we're already seeing that. I mean, even in the sort of primitive proto-AGI that we have now, they can read many times faster than a human can and ingest knowledge. So clearly they'll be able to learn much quicker. Now, learning to interact with the world, that can, a lot of that learning can happen in a virtual world. And again, the virtual world, of course, can be sped up. It doesn't, have to operate at human timescales. To believe that you can't speed that up significantly in a virtual world environment. And then the final experience of interacting with humans, of course, has to happen in the real world. But that's assuming you already have this massive amount of background knowledge available, and the interaction with humans to sort of learn things at human speed and real world speed, that might be a few weeks worth or a few months worth, of additional training that you need. But you can also do that in parallel once you have a system trained up with all the core knowledge that you need. You can make, 1,000 copies of it, and you could have 1,000 different people train it with the real world sort of pace, as it were.